Okay, students, so we're now in the second part of Unit 7, and the punchline of this unit is trigonometry. All right, and what does this exactly mean? Well, it's from the Greek. First off, before you even look at that, trig, triangle, 3. Right, tri means 3, metry means measurement. Just like how geometry means earth measurement, trigonometry basically means 3 or triangle measurement. It's a branch of math that studies the relationships involving lengths and angles of triangles. All right, that's a huge punchline, obviously, lengths and angles of triangles. The field emerged in the Hellenistic world during the 3rd century BC, so thousands of years ago, and applications of geometry for astronomical studies. In fact, trig is one of the most important things we'll learn in this school year. You'll use it again next year in Algebra 2, if you eventually make it on the pre-calc or whatever. It's just used a lot in construction engineering. It's very important. This might be some of the most important stuff we teach you in all seriousness. So Hipparchus is credited with compiling the first trigonometric table and he's known as the father of trigonometry, all right? This is Hipparchus. We'll give him some blue eyes. Oop. Can't. Anyways, that's him. All right. And trigonometry was developed based off the idea that given a specific ratio of sides, so given a specific ratio of sides, an angle must have a certain measure. All right. So basically, we're going to do two ratios, or a ratio of two side lengths in a triangle, and it's going to tell us what measurement is, or vice versa. All right. And we'll investigate this more in the near future. In the spirit of the class, we're only going to investigate the 3 relationships as follows. All right, so anyways, what is this? What is this right here? This is theta. This is a Greek letter. What's weird about Greek letters is you can spell them. You can spell theta, pi is a Greek letter, alpha, beta, so on and so forth. It's essentially x. All right, this is a variable. It's essentially the same thing as x. All right, just so you're not too scared about that. All right. So theta, and we use this for angles. Why? Got to use something. All right. So we have this triangle, and this is theta. Now everything I'm about to do is based off the fact that this angle is theta. Well, we have 3 sides. Well, the hypotenuse is always the hypotenuse. The hypotenuse never changes based on perspective. All right. Then we got the adjacent side. All right. So you got the hypotenuse. And then the adjacent side is the leg that touches theta, so that's what adjacent does. And then we got opposite. The opposite side does not touch theta. All right, so with respect to this angle measure theta, we have 3 sides: hypotenuse, adjacent, and opposite. All right. Now, ABC triangle, ABC is a right triangle with an acute angle theta. We have the following ratios, all right? So this is going to seem very foreign at first, but just muscle through it, and by the end of it, you'll say, wow, I'm really good at this. So we have sine. We have 3 trig ratios we're going to learn. The first one is sine. Now, us mathematicians, we're very lazy. We just abbreviate sine to S-I-N. That's not sin, still sine. So we have sine theta, and the relationship of sine theta is opposite over hypotenuse. All right, so we're starting very basic, and we're just writing out the ratios in English right now. Hypotenuse. And then we can also write as cursive O, H. That's a cursive O up there with a big long tail. Make sure to give it a big long tail so it does not look like theta or a 0. All right, now the next defined relationship is cosine. And we abbreviate that to COS, cosine, not cos. Cosine of theta is defined as the ratio of the adjacent side length divided by the hypotenuse, which becomes A over H. And then the last one we're going to talk about is tangent, T-A-N, tan. Tangent of theta is opposite over adjacent. We can write that as O over A. All right, so these are 3 trig ratios that we're going to investigate. All right, so we have an acute angle theta, and these are the ratios based off of that. All right, so this is what we're going to do. We're going to find sine, cosine, and tangent for angles A and B, and we're going to write each of them as a fraction. This is it. This is all we have to do. All right, so first off, let's look at angle A. Angle A right here. Now, I'm going to label this side with respect to angle A. The hypotenuse is always the hypotenuse. It's always opposite the 90-degree angle, the right angle. 4, side 4, touches, that's the adjacent side. This is the side that touches angle A. That's not the hypotenuse. And then we have the opposite. The opposite side does not touch it. So this is what we're going to do. We're going to do the sine of angle A. And then we're going to write these down a lot so we remember opposite over hypotenuse. I'm abbreviating just a little bit. All right, so the opposite side of angle A is 3. So it's going to be 3 over the hypotenuse, which is 5. And that's it. The sine of angle A is the ratio of 3 over 5. Cosine of angle A is adjacent over hypotenuse. Again, you just have to memorize these things, these the relationships and ratios. All right, it's adjacent over hypotenuse. So in this case, the adjacent to angle A is 4. The hypotenuse is 5. And lastly, we got tan of angle A, which is opposite over adjacent. And the opposite side of angle A is 3, and the adjacent side is 4. So that's it. That's the most basic punchline of trig right here, is writing the ratios themselves. All right, now we're going to do the same thing, but we're going to do it for angle B. So notice how some things change once we're now looking at angle B. The hypotenuse does not, though. The hypotenuse is always the hypotenuse. All right, 4 now is the opposite side. It does not touch angle B. And then this side now is the adjacent side. So the opposite and adjacent sides swap. All right, maybe you can try this on your own, or maybe you can just stay tuned and listen. But technically, you might be able to do this now. Again, sine is going to be opposite over hypotenuse. Now the opposite side is 4. The hypotenuse is still 5. Cosine of angle B is now adjacent over hypotenuse. The adjacent side to angle B is 3. The hypotenuse is 5. And lastly, we have the tangent of angle B, which tangent is opposite over adjacent. And now opposite side is 4, adjacent is 3. Interesting stuff. All right, cool. All right,